You ever just stop and think about what the world would be like if that giant asteroid, the one that wiped out the dinosaurs, had just missed? It's a classic sci-fi question for sure, but the scientific answer? Ooh, it's way more fascinating than you might think. All right, let's get into it.
So let's paint a picture. It's 65 million years ago. There's this 6-mile-wide rock hurtling through space straight for Earth. But in our alternate timeline, it just zips right on by. No cataclysmic impact, no nuclear winter, no mass extinction. So what happens next?
Well, that single near miss, that one tiny change in history, would have these absolutely massive consequences. It would kick off a chain reaction, a butterfly effect, that creates a completely different version of Earth's history. And it all starts with the creatures that were already on top. Now, this is where the dominoes really start to fall. Without that extinction event, the dinosaurs just keep going. Their 150 million year reign continues, unbroken. They are the undisputed kings of pretty much every single ecosystem. And for our tiny furry ancestors, well, that's really bad news. They're stuck in the shadows, staying small, nocturnal, basically just trying to avoid being someone's late-night snack.
And that's the whole key, right there. That asteroid impact wasn't just an ending for the dinosaurs, it was the starting gun for mammals. Without the ecological slate being wiped clean, there was just no room at the top. No opportunity for mammals to diversify, to get bigger, and eventually to lead to primates and, well, to us.
Okay, but if mammals didn't rise to the top, could something else have? This is where we get into one of the coolest, most mind-bending ideas in all of paleontology, the possibility of an intelligent dinosaur. Back in the 1980s, a paleontologist named Dale Russell was looking at this one particular dinosaur, Troodon, and he saw something really special. Troodon was already showing some super promising signs of intelligence. So Russell started to wonder, what if you gave it another 65 million years to evolve? What could it become?
And this is exactly why Troodon was the perfect candidate for this thought experiment. I mean, look at this. It had one of the largest brain-to-body size ratios of any dinosaur we know of. It had hands that could actually grab and manipulate things, and maybe most importantly, it had forward-facing eyes, giving it depth perception, stereoscopic vision, just like we have. These are all the key ingredients you need to start down the path toward higher intelligence.
So Russell's big idea ended up becoming this famous model, the Dinosauroid. It's this bipedal, reptile-like being with a huge head, an upright posture, and these intelligent-looking eyes. It's the ultimate what-if, right? A rival civilization, not from apes, but from dinosaurs. But here's the big question. Could it really have happened?
And this, my friends, is where that incredible sci-fi dream slams right into a biological brick wall. The whole Dinosauroid idea is amazing to think about, but when you actually look at the neurology, at the nuts and bolts of the brain, the story gets a whole lot more complicated.
The real question here isn't about having enough time or the right opportunities. It all comes down to the wiring. Could a dinosaur brain, even with millions and millions of evolution, ever develop the kind of architecture it needs for our level of intelligence?
And this, right here, is the absolute core of the problem. Mammalian brains and dinosaur brains are just built fundamentally differently. Our intelligence comes from our cerebral cortex, which is this really organized, 6-layered sheet of neurons. You can think of it like an expandable motherboard. You can keep adding new parts and then just fold it up to cram more processing power into the same space. Dinosaur brains, on the other hand, are more like their modern bird relatives. They have what's called a nuclear pallium. Think of that as a bunch of compact, hardwired clusters. It's super efficient for what it does, but it has one critical design flaw.
This fundamental difference in design leads to what you could call the brain's wiring problem. And it's pretty much the ultimate reason why a dinosaur civilization is just biologically improbable.
So to get to our level of intelligence, with language, with abstract thought, with complex tool-making, neuroscientists figure you need something like 200 distinct specialized areas in your brain. To put that in perspective, our earliest mammal ancestors had maybe 20. So getting from 20 to 200, that's the giant evolutionary leap we're talking about.
So here's how the problem plays out. In a dinosaur-style nuclear brain, every time evolution adds a new functional area, it has to physically wedge it in between the existing ones. This literally pushes everything further apart. The connections, the wiring between all these brain regions just have to get longer and longer. Eventually, the signal delay, the lag time, gets so bad that the brain becomes incredibly inefficient.
It's like trying to build a supercomputer where the processors are miles apart from each other. It just doesn't work.
And this is our brain's secret weapon. This is the superpower that mammals got. Our cortex can fold. All those wrinkles and grooves in our brain, they're not random at all. They are an absolutely brilliant solution to that wiring problem. By folding, our brain can pack in tons of new areas while keeping the connection distances between them super short and super efficient. A dinosaur's nuclear brain just couldn't do that.
So, what does this all mean for our alternate Earth? After all this, what would a world where the asteroid missed actually look like?
Well, that world would have been, without a doubt, spectacular. A vibrant, wild planet absolutely teeming with an incredible diversity of dinosaurs that had 65 million more years to evolve. It would have been way more dangerous for any mammal trying to make a living. But a world with a competing, intelligent species descended from Troodon, the neurology, the brain science, it all suggests that's highly, highly unlikely. The blueprint for human-level intelligence just wasn't there.
And this brings us to a really startling conclusion. Human intelligence, our intelligence, was not some inevitable endpoint of evolution. As the evidence strongly suggests, we are essentially a unique fluke. We're the result of a lucky break, of a weird quirk in brain architecture that our distant mammal ancestors just happened to have.
And that leaves us with a pretty profound final thought, doesn't it? Our entire civilization, all of human history, every piece of art, every scientific discovery, it only exists because 65 million years ago, a rock from outer space didn't miss. We are the beneficiaries of a cosmic catastrophe. It's just a humbling reminder of how unbelievably improbable our own story really is.